You're tuned into the deep dive. Today, we're digging into something pretty foundational in the Ruby web world, Rack.
That's right.
Now, look, many of us, we work with Rails all the time, right? But Rack, maybe the name rings a bell, but what it actually does, maybe less clear.
It's kind of the plumbing underneath.
Exactly. So think of this as us getting under the hood a bit. We're looking at an article by Alessandro Dias, How Does Rack Work? And also the Wikipedia page for Rack.
Good sources.
Yeah. And our mission really is just to pull out what Rack is, why it matters, and how it makes building web stuff in Ruby, well, simpler.
Definitely. And understanding Rack, even if you're mostly in Rails, it just clarifies how everything fits together. It's like seeing the foundations of the house, not just the rooms.
Right.
And, thinking about what things were like before Rack, that really shows why it was such a needed, elegant solution.
Okay, so let's paint that picture. We're talking what? Early 2007?
Around then, yeah.
Rails 1.2 was out, making noise. But, like Dias' article mentions, it wasn't just Rails. You had this explosion almost of other Ruby frameworks. Merb, Camping, Nitro.
From A's, Iowa.
Yeah.
A whole bunch were emerging. It was a really vibrant time for Ruby web dev.
Sounds exciting, but maybe a bit chaotic. And all these apps, they needed servers, right? Same as today. You had WeBrick, Mongrel, FastCGI. Those were common options.
And that was where the problem started, really.
Yeah.
You want different system parts to talk nicely.
Yeah.
Without needing tons of custom glue code.
Sure.
But back then, each server, WeBrick, Mongrel, FastCGI, they all had their own way of doing things, their own API, basically, for how a Ruby app should talk to them.
Ah, okay. So if you were building, say, Merb, it wasn't straightforward.
Not at all.
You couldn't just write your framework and expect it to work on Mongrel and WeBrick out of the box.
Exactly. You had to write specific adapters, these handlers, Dias calls them, for each server you wanted to support.
He mentions Mongrel Rails specifically.
That's a classic example. And even Rails itself, for smaller ones like Camping, they needed separate code, separate handlers for FastCGI and for WeBrick.
Wow, okay. That sounds like a lot of repeated work. Just duplicated effort across the board.
It really was. That duplication and just the lack of a standard, that's the core problem Rack came along to fix.
Yeah.
It begs the question, right? How do you unify that kind of fragmented ecosystem?
And the answer was Rack.
The answer was Rack. Both sources really highlight this. It popped up as this really simple API. Dias notes it was inspired by Python's WSGI, actually.
Right, WSGI. So Rack becomes this kind of middleman, a translator.
Yeah, standard interface. The key benefit, like you said, is it creates a common language, a protocol, if you will.
Right.
Frameworks use it to talk to servers. Servers use it to talk to frameworks.
So suddenly a framework like Sinatra or Rails doesn't need to know the nitty-gritty details of WeBrick versus, say, Puma or Unicorn today.
Precisely. Once Rack got adopted, it just changed the game. Frameworks just needed to be Rack compatible. Make sure they speak Rack.
And servers just needed a Rack handler.
That's it. Dias calls it plug and play for servers, which is a great way to put it. No more deep dives into server internals just to get your framework running.
That must have freed up a lot of developer time.
Oh, absolutely. And it made it easier to build other tools on top, too. Things that could work with any Rack-compatible setup.
Okay. So it's a standard interface, but what does a Rack application actually look like? Code-wise, what's the absolute minimum?
And this is where the elegance really shines, I think. It's incredibly simple. According to both sources, basically any Ruby object.
Any
object that responds to a method named #call. That's it. It can be a Rack app.
Just #call? No special inheritance or anything?
Nope. Just needs that method. That's the entry point.
Okay, so what does this #call method do? What does it get? What does it give back?
It gets one argument, which is crucial. The env object. An env is just a standard Ruby hash.
A hash containing
all the details about the incoming HTTP request.
Yeah.
Everything the server knows about it.
Got it. And what does #call return?
It has to return an array. And this array must have exactly 3 elements.
3 specific things. What are they?
Okay, first element.
Yeah.
The HTTP status code. 200 for, 404 not found, 500 for server error, that kind of thing.
Standard stuff.
Second is a hash of HTTP headers, like content type, cache control, whatever. And Dias makes a point here. The keys in this header hash have to be strings.
Okay, string keys for headers. And the third element?
The third is the response body, the actual content going back to the browser or client.
Like the HTML page or JSON data.
Exactly. And this body object needs to be something you can iterate over, something that responds to #each.
Huh.
Or, interestingly, it could even be another Rack app object that responds to #call.
Huh. Okay, so status code, headers hash, iterable body. That's the contract.
That's the core contract, yes.
Dia shows that super simple hello world using a lambda in config.uu. Can you break that down?
Sure, it looks like this. My app, hash and AV,
Hmm.
200 AHz, hello world. Then on the next line, run my app. So my app here is just a lambda, basically an anonymous function. It takes that env as input, though in this simple case, it doesn't actually use env for anything.
It just ignores it.
It just ignores it.
Yeah.
And it returns that 3-element array, 200 for status, an empty hash for headers, because we don't need any special ones, and then an array containing just the string hello world as the body.
Yeah, and the run my app part.
That's the instruction in the config.ru file that tells the rack server, okay, use this application object myapp to handle requests.
Gotcha. And then he mentions running rackup. What's that?
Rackup is just a command line tool that comes with the rack gem. You might need to gem install rack first.
Right.
Its job is to read that config.ru file, figure out your application, and start a web server running it. By default, it usually listens on port 9292.
And Dias shows using curl to hit localhost 9292.
And you get hello world back. Simple as that. Wikipedia also has a hello world, but using a class instead of a lambda.
Ah, showing that any object works as long as it has hashtag call.
That's exactly. Class hello world, def call nv 200 and run hello world.new. Same principle.
Okay, let's go back to that n hash pass into hashtag call. You said it holds all the request info. What kind of details are we talking about? It seems pretty important.
Oh, it's central. Wikipedia breaks it down nicely into two kinds of information. First, you get all the standard HTTP request stuff.
Like
Like the method get, post, put, delete, whatever. The full URL details the path, the query string, server info too, like the server's name, the port number it's running on, and all those HTTP metavariables the client sends.
You mean like the user agent string, except headers telling what content types the browser wants?
Exactly that stuff. Browser type, language preferences, content formats it understands.
Okay, so standard HTTP info. What's the second category?
The second category is data specific to rack itself or the server environment rack is running in.
Oh, like what?
Things like the rack version being used.
Mm-hmm.
The URL scheme is at HTTPS, access to the raw, unparsed HTTP data if you need it. An object for reporting errors back to the server environment.
Okay.
Information about concurrency, like can this app be called by multiple threads at once? And even details about server capabilities, like whether it supports things like connection hijacking for WebSockets or something.
Wow, that's actually quite a bit packed into one hash.
It really is. And as Wikipedia notes, if you start using middleware, which we should talk about, that ends hash can get even richer. Middleware might add session data, or logging tools, or user authentication info into NVAS as the request passes through.
Ah, so middleware can modify the NVASH too.
Absolutely. They can read from it and write to it. How context get passed along the chain.
Okay, cool. So we've got the input, the NVIF. Let's circle back to the output, that three-part response array. Status, headers, body. Can we dig just a little more into those?
Sure. The status code, as we said, signals the outcome. 200, okay, 400, not found or common. But there's a whole range defined by HTTP specs for different situations. Headers. Key value pairs in a hash. Keys must be strings. They give extra info about the response content type, text, HTML, content length, caching instructions, setting cookies, things like that.
And the body.
The body is the actual payload, the HTML, the JSON, the image data, whatever you're sending back. And remember, it needs to respond to hashtag each, so the server can potentially send it back in chunks, maybe.
Okay, good point.
Yeah.
Efficient for large responses.
Exactly. And Wikipedia mentions rack response. That's just a helper class provided by rack itself. It gives you a nicer, more object-oriented way to build up that response, right? Especially if you're doing complex things with headers or cookies.
Yeah.
It just makes the code cleaner than manipulating the array directly sometimes.
Makes sense. Just a convenience. So why is the status code first in the array?
Good question. Well, the server needs to know the outcome right away before it starts processing potentially complex headers or sending a large body. So having the status first is efficient.
Got it. Okay, so rack app takes n, does work, returns status, headers, body. Seems very clean. Now, you mentioned middleware earlier, and both sources talk about it quite a bit. What is middleware in Rack's world?
Yeah, middleware is a really powerful concept here. Think of them as layers or filters. They sit between the web server and your main application logic.
Filters.
Yeah, Dias calls them filters for the request or response. And the key thing is, middlewares are also rack applications. They follow the exact same API. They must have a hashtag call method that takes env.
Okay, wait. So middleware component receives the N, just like my main app,
Yep.
and it can look at the request, maybe change it before it even gets to my application.
Precisely. It can inspect the end, maybe modify it, add things to it, and then it typically calls the next application in the chain.
The next application. Could be another middleware.
Could be another middleware or eventually your main application at the end of the chain.
Mm-hmm.
And they can also intercept the response on the way back out.
Ah, so they can modify the status headers or body after my app has produced them.
Exactly. It forms this pipeline, or as it's usually called, a middleware stack. The request flows in through the stack, hits your app, and the response flows back out through the same stack in reverse.
That sounds incredibly flexible. Dias gives that my middleware example. What does that specific one do?
Right, my middleware.
Yeah.
It's designed to check the accept header from the client. Inside its call method, it looks into the end hash for the HTTP sect AP key.
Okay.
If the value of that header doesn't include the string text.tml, this middleware decides, nope, you're not authorized for this.
And it just stops the request there.
It stops it right there. It returns its own response. A 401, content type, text plain, not authorized.
Mm-hmm.
It doesn't call the next app at app.callNV.
But if the accept header does contain text TML,
Then it just calls at app.callNV, which passes the request down the line to whatever is next in the stack, maybe another middleware, or maybe the main MyApp Lambda we saw earlier.
that's a great example. It shows how middleware can enforce rules or add behavior. And the config.uu for that. You require the middleware file, then you define your app, then crucially you say, use my middleware before run my app.
Exactly. The order you use middleware in config.uu defines the order in the stack. It's significant.
So my middleware runs first in this case.
Correct. And dice shows the curl commands, right? If you send a request with accept.texthtml, you get the hello world from the main app.
But if you leave that header off,
Then my middleware catches it, returns the 401 not authorized, and the main app never even sees the request.
clever. And Wikipedia mentions that rack servers often add their own default middleware too.
Yeah, that's common. Things like middleware to catch exceptions from your app and display a nice error page instead of crashing the server, or middleware to validate that requests and responses actually conform to the rack spec.
So even a simple config.ru might have a few invisible middleware layers running.
Very likely, they provide some essential baseline stability and features.
Okay, so stepping back. Rack really came about to solve that specific problem, didn't it? Frameworks being too tightly tied to specific servers back in the early Ruby days.
Absolutely. That coupling was inefficient, led to duplicated code. Rack provided the fix.
And it seems like it worked incredibly well.
It really did. That simple standard API just decoupled everything. Frameworks could focus on framework stuff. Server developers could focus on server stuff as long as they both spoke Rack in the middle.
It fostered modularity.
Modularity, flexibility.
Yeah.
It probably lowered the barrier for new frameworks and servers to even appear because they had a clear target to integrate with.
And it's not just history, right? Both sources make it clear Rack is still fundamental today.
Oh, absolutely. It's the bedrock for Rails, for Sinatra, for basically any mainstream Ruby web framework.
Even if you're using Rails and don't see Rack code every day.
It's there. It's the layer handling that crucial communication between your Rails app and Puma or Unicorn or whatever server you're using.
And its influence spread, too. Wikipedia lists examples in other languages. JavaScript's Jack.js, Perl's Plack, .NET's Owen.
Yeah, that really shows the strength of the core idea. This concept of a minimal standard interface between application and server, it's proven valuable across different ecosystems.
It's a powerful pattern. And that other Wikipedia example, the Hello World class, it just reinforces that as long as you have that hashtag a call method returning the right three things, you're a Rack app. You fit into this ecosystem.
Exactly. Run helloworld.new works just as well as run my Lambda.
Mm-hmm.
And like Wikipedia says, tons of Ruby apps are Rack compliant. It's just the standard way.
Okay, so wrapping this up, the big takeaway seems to be Rack is that vital standard interface. It connects Ruby web apps to web servers. It simplified everything by decoupling them.
Promoted modularity, reusability, made things just work together better.
And we've seen the core pieces, the hashtag call method requirement, the env hash carrying all the request context, that three-part response array status, headers, body, and the power of middleware to add layers of functionality.
And honestly, understanding Rack, even just the basics we've covered, it gives you a much deeper insight into how your Ruby web frameworks actually function under the covers.
It demystifies things a bit.
Yeah, takes away some of the magic and shows you this, well, this really elegant contract at the heart of it all.
It really makes you think, though. How much did this simple idea, this standard interface, influence not just Ruby, but web development more broadly? What kind of innovation does that common ground unlock for developers everywhere?
That's a fascinating question to consider. The ripple effects of standardization like that can be huge.
Definitely something to chew on. Well, thanks for digging into Rack with us today.